Hello guys, welcome back to my YouTube channel. Today I am going to solve day 11 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 402, remove k digits. Okay, so actually this problem is marked as medium, but it is a little bit tricky actually. Okay, and this question is asked in Microsoft Meta, so mark this question as important as well. Okay, so now first of all, let's read the problem statement. So here we have given a string num which is representing a non-negative integer num and an integer k, and we have to just return the smallest possible integer after removing k digits from num array. Okay, this non-negative number. Okay, not array, so this is a non-negative integer num. Okay, so now let's understand this with examples first. Okay, so let's say if I give you some set of numbers. Okay, so let's say I am giving you some set of numbers, and numbers are like this. One number is 7 and one number is let's say 2, one number is 5, one number is 8, and one number is 1. Okay, so let's say these 5 numbers are available and I am asking you guys to make a smallest number for me. Okay, out of these 5 numbers. So how you guys are going to make the smallest number? Okay, so definitely you are going to form a number like this: 1 2 5 7 8. So using these 5 numbers you are going to form a number like this, which is going to be the smallest one, right? 1 2 5 7 8. Okay, so here how this the concept of math that this number is the least significant and this number is the most significant. Okay, so this number is at 1's place, right? This number is at 10th place, this number is at 100th place, right? This number is at 1000th place, right? And this number is at 10,000th place, right? Ones, tens, 100,000, 10,000th place. Okay, so this number is formed using this concept, right? 8 into 1 is 8, 7 into 10 is 70, 5 into 100 is 500, 2 into 1000 is 2000, 1 into 10,000 is 10,000, right? So if I add all these numbers, then what number I will get? I will get this number. Okay, so one thing is clear, that this value is least significant. Okay, and this value is most significant. Okay, so I hope that this concept is clear. Okay, so this is at 10,000 place and this value is most significant. Okay, okay, so this is clear. And to form a smallest number, what I am doing in this problem, in this example, I am arranging the numbers in increasing order, right? So see, at the most significant bit, smallest number is there. Okay, and after that so this is in increasing order, right? All the numbers are in increasing order. After 1 I go to this 2, then after that I go to 5, then after that I go to 7, then after that I go to 8. Okay, and this so this is the largest number, right? And this is at least significant position. This is the smallest number and this is at the most significant position. This number has 10,000 value, but since we are making the smallest number, that is why this number is got placed here. Okay, so I hope that this is clear. Okay, now we can't use the greedy approach to solve this problem. Okay, so let me copy example here, example number 1. Okay, so here I have copied this example. Okay, so here but you guys, let's say someone is saying let's do one thing, let's remove the, since case 3 now, so people, so definitely question is asking us to remove the 3 elements. Okay, so that we will get the smallest number. So let's say some person is saying that first let's do one thing, let's delete the largest numbers. Okay, let's delete the largest number from these numbers. Okay, so from this number let's delete the largest numbers. Okay, so let's say we have deleted this 9, we have deleted this 4, we have deleted this 2, this 3, right? So we have deleted the largest numbers, okay, in this particular number. So then we are left with 1 2 2 1. Okay, so is this our answer? No, this is not our answer. So here our greedy approach is going to fail. Okay, greedy approach is going to fail, right? And can we write this number like this: 1 1 2 2 3 4 9 in increasing order? Okay, can we write it like this? No, we can't shuffle it. We can't shuffle the numbers. Okay, so this approach is also wrong. This approach is also wrong. Our greedy is also failing, okay, using this approach. But you guys are aware of this. Okay, you guys are aware of this. So now let's do one thing. From this number let's try to make a strictly increasing number, because if we make a strictly increasing number like this, okay, increasing number, okay, then definitely we are going to get the output like this, some output like this. So what I am saying here, so let's say this number is given to me 1432219. Okay, so let's say this number is given to me. Let me erase this. Okay, so now you guys know that we can't apply a greedy approach here, right? So let's say this is a number given to me. So what I am saying, I have to form one number. Okay, so right now my k is equal to 3. K is equal to 3. So first, I know about this. Okay, so smallest value is at most significant bit. Okay, most significant position, and the largest value is at the least significant position. Okay, I know this thing. Okay, so now let's say I'm going to form my number, so I'm going to start from this position only. Okay, so first I write 1 here, and after that 4 comes. So this 4 is greater than 1. Okay, this value, this 4 is greater than 1. Okay, so I am going to make strictly increasing only, right? So yes, I'm going to write it 4. I'm going to write 4 here. Okay, then after that 4, I go to this 3. Can I write this 3 here? Since 4, my 4 is greater than 3, so I am not going to write. Okay, so I have to remove a number. Okay, so and which number I am going to remove? Because see, this is my 1. After 1 I go to 4, and then I'm coming back to 3. Okay, so this is what's happening, right? So from 1 I am going increasing. My number is increasing, value is increasing 1 to 4. Then there is sudden drop. Okay, I want a strictly increasing order, right? I want it in an increasing order. Okay, increasing order 1 2 5 7. I can't place a number like this. I can't write it like this 1 5 2 7 8. This is not a smallest. Smallest is this one only, 1 2 5 7 8. Okay, so let's say I am planning to maintain the order. Okay, so now to maintain the order, so this is wrong now, so I don't want this 5 here. Okay, because after that I am getting one least value, so let's say that I am going to go from 1 to 2. Okay, okay, because I am want a 5-digit number which is smallest. Okay, so definitely I don't want to place 5 after 1, but I can place 2, right? I can place 2. So here I am going to top right 1 1 to 4, then I am going to 3. Okay, so let's say I have removed this 4 here. Okay, so here I have removed this 4. I have removed this 4, and now my 3 will come. Okay, 3 will come here. Okay, 3 will come here after, because my 1 my 1 is less than 3. Okay, so this is going like this only, 1 to 3. Now I have removed 4, because here I see one discrepancy, so now I have removed this. So 1 to 3. Okay, this is the connection. So now since I have removed one number, so now my k will become 2. My k will become 2. Okay, right? Then after that, can I write 2 here? So 1 to 3, then again some smaller value. So I don't want to do it like this. Okay, this is wrong, because here it is decreasing. So what I'm going to do, I'm going to remove this 3. Okay, definitely if I'm going to involve this 3, definitely I want it after 2. Okay, but I can't place this 3 before this 2. Okay, in that case I'm not going to get the smallest number. Okay, so what I'm saying here, if I have 3 numbers 1 3 2 and 1 2 3, definitely I'm going to place 3 after 2. I'm not it's not a good idea to place 3 before 2. Okay, so that is why I am removing this 3 now, because I can remove that, because k is equal to 3, because we can remove the 3 digits. Okay, so I have removed this 3. Now I'm going to write 2 here. Okay, so now my this is looking like this from 1 to 2. Okay, and definitely I have removed 3 as well. Okay, so now my k will become 1. Okay, so I have removed 2 numbers, so now my k is equal to 1. After that, 2, can I write 2 here? Yes, there is no impact, because it is like this only. Okay, I can write 1 2 2, which 2 come first, that doesn't matter. Okay, I am writing 1 2 2. After that, this 1 will come. Okay, after that this 1 will come, but can I write from 2, can I go to go like this from 2 to 1? No, this is not a good idea, right? If there are 4 numbers given to me, 1 2 2 1, so what's the good idea? Good idea is this one only, 1 1 2 2. This one is good idea, and this one is still better. This thing is still better than this one. Okay, this one is still better than this one. Okay, and this is the best thing. Okay, so here this is wrong, right? This is wrong. From 2 to 1 I'm going, so my k is 1 right now, so I have a chance to remove my number. Okay, so what I'm going to remove, I'm going to remove this 2. Okay, so I have removed this 2. Here I am writing 1. Okay, so what it look like this, 1 2 and 1. Okay, this is looking like this, so I have removed this 2 as well, so my k is equal to 0. So right now this is also not good, right? 1 2 1, from 1 to 1. Okay, I have removed these 3 numbers. Okay, and it is looking like this, 1 2 1 again, but I can't do anything. I can't do anything because my k is 0, because my k already becomes 0, because I have already deleted 3 integers. Okay, so I can't do anything, so I'm just going to write 1 here, and then after that 9, but my k is already 0, so I can't do anything, so I have to write just 1 2 1 9, and see, this is my output, right? So I hope that example 1 is clear to you guys, right? Okay, so now let's understand this with example 2 and 3 as well. Okay, so now this is my example 2. Okay, 102210200 is a number. Okay, when we can remove 1 digit. Okay, so why I am starting from left, because we have to maintain the orders, right? Because if I'm going to start from my left, then only I can check if the numbers are increasing. Okay, so it's a good idea to start from left only. Okay, so here I have removed 1 digit. Okay, so from first see 10200, and I kind of remove 1 elements. Okay, so after that so see, in this example first 1 will come. Okay, then after 0 will come. Okay, 0 will come, so it's not a good idea. If I have 2 numbers, 1 0 and 0 1, so which one is smallest? Smallest is this one now. Okay, so definitely this is not a good idea. So what I am going to do, I am going to remove this 1, and my k will become 0. Okay, and now from 0 I am going to start. So after 0 new value will come, 2 will come. Okay, then after that I can't do anything, I have to add these zeros. Okay, I have to add these zeros, 0 to 0, because k is already 0. So this is the number that I'm going to get. Okay, 0 2 0 0, but I can remove this value, because this is not a significant. Okay, this doesn't have any significance. Okay, this is 0, so I'm going to write a code like this. I'm going to remove this zeros as well. Okay, this 0 as well from the starting. And one more thing, yeah, now you will get one more clarity here. So if my num, what is the length of my nums array in this example 3? So length is 2. If the length of my nums array is equal to the value of k, then that simply means that I can remove all the elements in my nums. Okay, in my nums this number. Okay, not array. Okay, so I can remove all the numbers, right? So in that case we have to just return the output as 0. Okay, so 2 numbers are there, I have removed all the numbers, so I am going to just return output as 0. Okay, so this is clear. Okay, so from this example, okay, so see we can implement actually stack here as well. Okay, we can implement stack. Why we can implement stack here? So since we are or removing the elements. Okay, we are the popping the elements. If any element is greater than our previous element, then we are popping that. Okay, all these things we are doing. Okay, so we are going to maintain one order. Okay, non-decreasing order, something like that. Okay, so that is why we are going to call this stack as monotonic stack as well. Okay, so here how we are going to implement this in stack. So first, number one, I am going to push. Okay, then after that 4 will come. 4 is greater than my stack dot top element, this peak element. Okay, then I am going to just push this 4 into my stack. Then after that 3, can I push this 3 into stack? No, I can't push this 3 into stack. Why? Because 4 is greater than 3. Okay, so for that purpose what I'm going to do, I'm going to remove this 4. Okay, and then push this 3. Okay, then after that 2 will come. So can I push this 2 into my stack? No, because this 3 is greater than 2. So I am going to remove this 3 and just I am going to add 2. Okay, so I have removed 2 numbers. So now my k is equal to 1. After then again 2 will come, so just I am going to add. After that 1 is trying to come here, but since this top value of stack is greater than my 1, so I am going to remove this 2, right? And now my k will become 0, and here I am going to add 1. And can I push this 1 into the top of my stack? Yes, I can push, because my k is already 0. I can't do anything. After that I'm just going to add all the numbers. So this is my stack. Okay, this is we can achieve this using stacks as well. Okay, so after that see, I have to just print the elements like this. Okay, so I hope that this is clear to you guys. Okay, so first we are going to maintain an order. Okay, and order is going to be strictly increasing. Okay, strictly increasing, I can't say strictly increasing, because I can say just it will be increasing. Okay, not strictly increasing, because we can get 2 like this number. Both the numbers are same here. Strictly means simply greater than 1, 2, then 3, no, then 4, no 4, no 4 will come. 1, 2, 3, 4, 5 will come, 6 will come, like that. Okay, this means strictly increasing. Increasing means we can write it like this: 1, 2, 2, 3, 4, 5. Okay, so two same numbers will come, can come, right? So I hope that this is clear. Okay, now let's write the code. Okay, let's write the code and let's see. So first of all we are going to create a stack. Okay, so in stack, this is going to be my stack of characters. Okay, stack, new stack, and after that first let's check if the length of my nums array, if num dot length, this string, right? It's a string, so I have to write like this: num dot length is equal to k. Then in that case we have to just return a string, since we are returning string, so I can write it like this: return 0. Okay, so this is clear, right? Then after that, once this is done, after that I am going to iterate over each digit in my string. Okay, so let's convert it into char array, so I can let's use for each loop. Okay, let's try to use for each loop. So for character, this digit, okay, this character, and what is my now string? It's num, and let's convert it to char array. So to char array function, so this is done. So now I am going to iterate over each digit one by one, and then inside this I am going to check, I'm going to run one while loop. Let's run one while loop, and this while loop is going to check if my k value is greater than 0. If my k is greater than 0, and if my stack is not empty. Okay, if my stack is not empty in this case, and it will also check if the top element stack.peak, if my top element in the stack if that element is greater than the element that I'm going to insert right now. Okay, so if this is the case, then in that case I have to pop the topmost element from my stack dot pop. And if I pop, that means I am removing some element, so that simply means I have to reduce the value of k minus minus. Okay, k to k minus 1. Okay, this is what I am doing inside this while loop. And every time I am pushing my element, okay, I am pushing the element in stack dot push. So character by character I am pushing, so character digit, so I am going to push digit here. Okay, so this is done. Okay, so I hope that this piece of line code is clear to you right now. Then I have to remove the retaining digits from the I have to remove the remaining digits from the end. Okay, so let's say let's say one thing. Let's say we have a number like this 1 2 3 4 5. Okay, and in this number I'm going to trying to push this into stack one by one. So after 1 I can push this 2, after that I can push this 3, after that I can push this 4, after that I can push this 5. Okay, and k is given to me 2 in this case. Okay, k is given to me 2 in this case. But here see, in my code I am only subtracting the value of k in this case, in this particular case, if my stack dot peak is greater than digit. Okay, in this case only, if my stack is not empty and my stack dot peak is greater than digit and my k is greater than 0, in this case only I'm decrementing the value of k. I have to delete the characters, right? But this string okay, characters or digits in this string is already in increasing order. I didn't get the chance to remove the k. So once this happens, then after that again I'm going to run one while loop, and in the while loop I am going to check if my stack is not empty. Okay, so right now my stack is not empty and my k is greater than 0. Okay, then in that case I am going to remove the elements from top. So here I have removed this 5, so now my k will become 1. Then after that I am remove this 4, then my k will become 0. Okay, so what is left out? 1 2 3. Okay, this one is left, so 1 2 3 is going to the output. Okay, so this is the best solution after removing 2 digits. Okay, so I hope that this thing is clear. Okay, so here how this is the okay scan. If let's say if this number is like this 4 3 1 2 5, something like this, then in that case first 5 will come, then 2 will come. Okay, this is going to be different. Actually this answer is going to be different. 5 to 2, this is not the best way, so my k will become 1, so this is got removed. Then 4, then 3 will come, so I have to remove this 4, so now my k is 0. Okay, 2 3 1, so this is going to output, but in this case output is 1 2 3. Okay, so this is some other example. Okay, so you can ignore this. Okay, so I hope that this is clear. If the numbers are already sorted and we are not able to reach till this, if my k is still greater than 0, then in that case I have to remove the elements from the end. Okay, from the topmost of stack. So same thing what I have explained. If my stack is not empty and k is greater than 0, this is what I'm going to write now after this. So this simply means I am removing the remaining digits from the end. Removing the remaining digits from the end. Okay, while k is greater than 0 and you can check if my stack is not empty. If stack is empty, then doesn't matter. Okay, if my stack is not empty, then in that case we have to pop the element from the top of my stack and I have to subtract the value of k. That's it. This is done. Then after that we have to construct the result string. Okay, so let's use string builder. Okay, so your concepts related to string builder will also be clear in this video, I think. String builder result is equal to new string builder. Okay, so now after that, while my stack and while I'm going to run one while loop, while my stack is not empty. Okay, I'm just going to append the values in my result. Okay, result dot append one by one. Result dot append stack dot pop. Okay, so I have just append all the elements in my result string builder, right, from stack. This is done. After that, reverse this result, right? We have to reverse it because we are adding the values like this 5 4 3 2 1. But in this case, right, after k is equal to 2, so I have removed two elements, so I am going to get the values in my result like this, so I have to reverse it. 1 2 3 is the order, right? So result dot reverse. Okay, this is going to reverse my string builder, okay, whatever I have created. Then after that, this is done. I have to remove the leading zeros as well, right? Remove the leading one, then number is 0 2 0 0, but we have to remove the leading 0 as well, no? So after that we have reached 200. Okay, so for that, can I write it like this? While my result dot length, if my result dot length is greater than 0, okay, this is what I'm checking. Result dot length, this is a string now, so I have to write it like this. Result dot length is greater than 0, is greater than 1. Okay, and result dot char at index 0. Okay, if this is equal to 0, then just delete this char. Result dot delete char at index 0. Okay, and in the end we have to just return our result, return result dot to string. Okay, now let's run the code and see. Okay, so line number 26, we are facing some issues in line number 26. Result dot length is greater than 1. Let's run it again, and result dot char at. Okay, so all the solutions are accepted, right? So here 1 2 3 4 5. Okay, let's create some more test cases. 1 2 3 4 5. Okay, and k is equal to 2. K is equal to 2, and if number is like this 5 2 4 3 1, 5 2 4 3 1, and k is equal to 2 only, 5 2 4 3 1, and this is clear, this is clear, this is also clear, this is also clear. 1 2 5 7 8. Okay, so this is okay. And one more test case that I want to show you guys, this one 1 0 2 0 0, 1 0 2 0 0. Here k is 1, but here what I am doing, I am, instead of 2 I am writing 0 only. Okay, so after removing 1 I am going to get output as 0 only, right? So let's run. So first test case, yeah, you guys are clear how we are getting the output. Okay, this one I have already explained now. This is our example 1. Okay, then this is also clear. After removing 1, okay, so output 200, I have removed this 0. Then this is also clear. If the num length is equal to this k, then 0. 1 2 3 4 5, removing the 2, so from the end only I am removing if it's already sorted order. Okay, 1 2 3 4 5, and we are not able to decrement the value of k, then from the end we have decremented. That's what's happening here at this position, right? So this is clear. So here when my output input is like 5 2 4 3 1, and then see what I'm getting. Where is this test case? 2 3 1, right? 5 2 4 3 1 2 3 1. So here I'm getting 2 3 1 as well, right? So this is also good. So here see output is 0. If I remove this one, then everything else is 0 only. Okay, so here I am okay, so here see if my result dot length is greater than 1, only in that case I have to execute. So I am going to check here till here. Then this one I don't need to check, because if my result of length is equal to 1, then simply return that. Now if it is 0, then return 0. If it is some other number, then return that number. Okay, so that is why result of length is greater than 1. Because if I write here greater than 0, then in that case it will just return an empty string. Okay, I don't want to return an empty string. Okay, so if it is 0, so let's return 0. Okay, so what I'm saying here, okay, so if I write 0 here, then what's going to be output? So it is going to return empty string. Okay, and that's what I don't want. See, this test case failed. Okay, case 6, this test case got failed. So that is why I'm writing here 1. Okay, so I have explained this thing to you guys as well, right? So these are the corner cases. Okay, so that is why this is one corner case and this is also one corner case, this case 3. If both the sizes are same, then I am handling this here only. Okay, so now let's submit the code, right? So see, our solution is accepted. So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Okay, and till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.